Today we'll be doing the integral from 0 to infinity of x divided by a hyperbolic cosine of x dx. And to start off, we'll use the fact that the hyperbolic cosine of x is e to the x plus e to the minus x divided by 2. So now replacing this in the integrand, we have the integral from 0 to infinity x divided by e to the x plus e to the minus x over 2 dx. And then we have twice the integral from 0 to infinity of x divided by e to the x plus e to the minus x dx. And from here, multiply the numerator and denominator by a factor of e to the minus x. So we have e to the minus x divided by e to the minus x. So now we're going to have twice the integral from 0 to infinity x times e to the minus x divided by 1 plus e to the minus e raised to the negative 2x power dx. And now we use the fact that 1 over 1 plus e raised to the negative 2x is the sum from 0 to infinity, negative 1 to the k, and then we're going to have a e to the negative 2xk power. So now replacing this into the integrand, we have twice the integral from 0 to infinity x e to the minus x, and then the sum from 0 to infinity, negative 1 to the k, e to the negative 2xk power dx. And from here, we'll swap the sum and integral. So we're going to have twice the sum from 0 to infinity, negative 1 to the k, and then the integral from 0 to infinity of x e to the negative x times e to the negative 2xk power dx. But we'll notice that e to the negative x times e to the negative 2xk is the same thing as e to the negative x minus 2xk. Factor out the net x, we have a e to the x times negative 1 minus 2k, and we could factor out the negative, so we have a negative x times 2k plus 1. So now replacing this in the integrand, we have twice the sum from 0 to infinity, negative 1 to the k, and in the integral from 0 to infinity, x times e to the negative x times 2k plus 1 dx. And from here we'll make a substitution. So we're going to let t equal x times 2k plus 1. Solving for x, we have x is t divided by 2k plus 1. And that means that dx is 1 over 2k plus 1 dt. The bounds of integration here won't change. So now we're going to have twice the sum from 0 to infinity, negative 1 to the k, and then the integral from 0 to infinity of t divided by 2k plus 1 e to the negative t, and then we're going to have a dt over 2k plus 1. So we have a twice the sum from 0 to infinity, negative 1 to the k, and then divided by 2k plus 1 quantity squared, and then the integral from 0 to infinity, t times e to the minus t dt. But this integral is just the gamma function evaluated at 2, which is equal to 1. So this collapses to 1, and so we're left with twice the sum from 0 to infinity, negative 1 to the k divided by 2k plus 1 quantity squared, which evaluates to twice of Catalan's constant. So now we could say that therefore the integral from 0 to infinity of x divided by hyperbolic cosine of x dx is equal to twice Catalan's constant. So that is the final result.